Let's go into the whole main function. So we have to iterate for t days. So I can use a while loop while t minus minus. So if t becomes 0, then we will come out of the loop. So while t minus minus, we have to check how many elements are in the queue. I have to consider the example here: 3, 3, 2, 0, 1, 1, 2, 1, 1, and 2, 1, 1. These two elements will be in the queue, which are 1, 0 and 2, 0. So if I consider these two elements, then the size of the queue will be 2. So I will collect the size of the queue, which will be q dot size. So if size is 0, then we have traversed through all the rotten apples present in the grid. So there is no more rotten apples to be checked. So we can directly exit the iteration or this while loop. So if size is 0, then we will break out from the loop. And if size is not 0, then we have to check for all the apples present in the all the adjacent apples to the apples present in the queue. Now what we have to do is, so we have to traverse through all the elements present in the queue. Now I will collect each and every element in the queue by using q dot friend. We collect the first element in the queue, which is this at the current moment, and after this I will pop this element out of the queue. I will pop this element, and we have to check all the 4 sides of this. So in order to check the 4 sides, we have explained earlier, 0, 0, and it can move 1 unit to the right side, 1 unit upward, or 1 unit to the left side, or 1 unit downward. So these are the 4 moves that we can take. So we have to check all these 4 adjacent apples, and if there is any fresh apple, then we have to rotate and add it to the queue. And if we don't find any fresh apples, then we don't have to do anything. So after removing this, we have to traverse through this. In order to do this easier, we can use 4 different conditions, like we have to check these. In order to reduce the code, we can use arrays, like index of 4 equal to, I will go in this direction. So start from 1, the second element will be 0, minus 1, and 0. In the similar way, in div of 4 equal to, start from here 0, and here 1, here 0, here minus 1. So if I have to go this direction, then I have to take this element and this element and add it to the current element in the queue, which is 1, 0. I will take int x is the first element, which is 1, so which is a p dot first, and int y is equal to p dot second. Now we have to do 4, we have to check the 4 adjacent sides of it. So for int I is equal to 0, I less than 4, I plus plus. Now I have to calculate the current position. If we make this move, what will be our current position? So in current x will be dx of I plus x, and in the similar way we can calculate in current of y, which will be dx of dy of I plus y. So when we move here, we have to check whether this apple is rotten or not. Before we check this apple is fresh or rotten or empty, we have to make sure that this current x and current y are always in the bounds, so that we can check whether this element is present in the grid or not. So if it moves out of the bounds like this, or this way, or this way, or this way, so we have to make 4 checks before proceeding to accessing the element at the position. the four checks will be if x current x less than 0, or current y less than 0, or current x greater than the number of rows, and current y greater than the number of columns, then we don't have to do anything. So we will add continuous statement. And now if we have to check whether the apple at the current position is fresh or not. If it is fresh, what we have to do, we have to add that particular address of the indexes to a queue and make the apple row10. So I will check if array of current x, current y is fresh. If it is fresh, what we have to do, queue dot push, we will make the pair, we will add this pair to the queue and make the apple row10 array of current x, current y, 2. So this is our loop. After, so if we make it right, and in the first position we have this 1 0, I pop this, so we have x equal to 1 and y is equal to 0. Now I will be checking 4 sides, so the first one will be 1 and 0. So if we add, let's take 4 iterations, so current x and current y, what will be the 1 plus 1, 2 and 0. So we have to check whether this is in the bounds. Yes, this is in the bounds. So if this is in the bounds, then I will check whether this is the fresh apple or not. So if we go there and check what is two and 0, this will be the element. This apple is already written, so we don't have to do anything. And then later what we have to do, we will go to the next element, which will be adding 0 and 1. So if I check that, the current x will become 1 plus 0 0, and current y will become 0 plus 1. So 1 plus 1, 1 plus 0 is 1 and 0 plus 1 is 1. So we will have to check 1 and 1 are in bounds. Yes, they are in the bounds. And now we have to check whether the current element is fresh or not. So if I go there and check 1 1, which is this apple is fresh. So what I have to do is I push this to the queue. So this is your queue, and I am pushing 1 comma 1 to the queue, and then I am making this apple as row 10. And now with the next run, I have to check this -1 and 0. If I check this -1 and 0, then current x will be 0 and current y will be 0. So we have to check the element at the 0 and 0, which is in the bounds, and hence I can go there. This is an empty element, so we don't have to do anything. And if I go to the 4th iteration, which is 0 and -1, so current x will remain 1 while current y will become -1. This is out of the bounds, so we don't have to do anything, and we'll continue. We have done 4 iterations of the particular element. We have checked all the 4 adjacent elements, and then we will move on to the next element in the queue, which is 2 comma 0. After we traverse through all the adjacent sides, this apple will also become row 10. And since we are doing this only for the current size, which at the starting is 2, because of this element is not present at the starting of this while loop, so this size will become 0, and then we will exit out of this loop, and then again t will be decreased by 1, and then again the loop starts, and then it finds this apple will also be added in the previous iteration, so this will be 2 comma 1. So this is also deleted, and again 2 elements are there in the queue, and so again the size will be 2, and again the iterations will take care, and then these apples will row 10, and as t becomes 0, and these 3 apples will be added to a queue. Since the t is 0, we will exit out of this loop. So as we are exiting out of the loop, we have to find how many fresh apples are still remaining here. In order to find that, we can directly use a for loop. We have to traverse through for int I 0 to m, and then for int j 0 to n, we have to find if array of I of j is 1. We can take a count variable which will be 0 at the beginning, and if it is 1, then we will increment the count. In this way, if we print the count, that is the answer we are looking for. So this count variable is the number of fresh apples remaining at the end of the tth array. And this particular condition is helpful when all the apples in the grid are row 10, and all the apples and all the adjacent sides of each and every apple is checked, and there are no fresh apples to get row 10 or to be checked. Then this condition helps in quitting the loop instead of performing the loop for t, because this will help in decreasing the time complexity. If we perform the loop t irrespective of this, then we are performing this for t, and all this will continue for q dot size. So if we take the worst case condition, then it will be n. So O of t times n will be the worst case condition. But if we use this one, then we maximum perform if all the apples will have to be checked, then if consider this case, if all the apples in the grid or the basket are row 10, we have to check each and every adjacent of this element, then that will be n. So O of n, and since this will be running for n times, so we get O of n square as the worst case time complexity. So this is the worst case time complexity, and without adding this, we will be having O of t into n. It depends on the t. It might be greater than O of n square. So this is our time complexity.